In the diagram opposite, AE equals 6 centimeters, EC equals 2 centimeters, BC equals 10 centimeters, BD equals 8 centimeters, and the angle ABC, so this angle here, is equal to the angle AED, so this angle here. Part 1, name two similar triangles and explain why they are similar. Part 2, calculate the distance from A to D. And part 3, calculate the distance from D to E. To show that two triangles are similar, so similar triangles have three equal angles, but their side lengths are different, but they are in the same ratio. It is only necessary to show that two pairs of angles are equal. This is because the third angle must then be equal. So if we prove that two angles are equal, we automatically know that the three angles are equal, and we automatically know that they're similar triangles. So let's start by labelling some of our lengths. So we have AE equal to 6 centimeters. So I've labelled A to E as 6 centimeters. EC equal to 2 centimeters. EC equals 2 centimeters. BC equals 10 centimeters. BC equals 10 centimeters. BD equals 8 centimeters. BD equals 8 centimeters. And the angle ABC equals the angle AED. So I've done those two angles in green. So we're going to start off by naming two similar triangles and explain why they're similar. So the similar triangles are going to be ABC, so ABC, so the large triangle itself, and ADE, so the smaller triangle that's inside the bigger triangle, as the angle ABC, so ABC, is equal to the angle AED, so that was given to us already, so they're done in green. The angle BAC, so BAC, is equal to the angle DAE, and that's done in orange, and they're definitely equal because they're a common angle. And so the angle ACB, so ACB, is going to be equal to the angle ADE. So this angle here, done in purple, must be equal to this angle here, also done in purple, because they're the remaining angles. We've already proven that two angles are the same, so the third angle must automatically be the same, because the angles in a triangle must always add up to 180 degrees. Part 2, calculate the distance from A to D. So from A to D, so I've labelled this as X. So we're going to let AD equal X and DE equal Y. Then the distance from A to B, done in yellow, must be equal to AD plus DB. So AD plus DB, so basically X plus 8. X plus 8. So I'm going to draw the two triangles out separately. So we have the triangle ABC, and the triangle ADE. So we already know that the angle ABC, so this angle here, is equal to the angle AED, this angle here. And we know that the angle BAC, this angle here, is equal to the angle DAE, this angle here, because remember they're a common angle. And the angle ACB, this angle here, is equal to the angle ADE. So we proved that in part 1 of the question. We know that the distance from A to E is 6. That was given in the question. We know that the distance from A to C is 8, because 6 plus 2 is 8. We've labelled AD as X, and now we're going to call AB X plus 8. So by theorem 13, we're going to take sides opposite angles 1 and 3, and we're going to cross multiply. So angle 1 is here, so the side opposite is 8, and angle 1 is here, and the side opposite that is x, and angle 3 is here, the side opposite that is x plus 8, and angle 3 is here, and the side opposite that is 6. So theorem 13 is proportional sides in similar triangles theorem, and it says that if two triangles ABC and DEF are similar, then their sides are proportional in order, i.e. AB over DE is equal to BC over EF is equal to CA over FD. So we are going to create fractions with our corresponding sides. So we're going to have x over 8, because those two sides are corresponding with each other. So x over 8 is equal to 6 over x plus 8. 6 over x plus 8, because these two sides are corresponding with each other. So we have x over 8 is equal to 6 over x plus 8. So I've taken the smaller triangle side values to be the numerators, so x and 6, and the larger triangle side values to be the denominators, so 8 and x plus 8, 8 and x plus 8. But it doesn't matter if these were to go on top. So then we just cross multiply and then solve for x. So we're going to have x multiplied by x plus 8, and 6 multiplied by 8, which is 48. X multiplied by x is x squared. X multiplied by 8 is 8x. Bring the 48 over the equal sign, it becomes minus 48, equal to 0. Next we're going to factorise. So get x minus 4 and x plus 12. And then we're going to let each of the set of brackets equal to 0 and solve for x. X minus 4 equals 0, so x is 4. X plus 12 is equal to 0, so x is equal to minus 12. Now x cannot be equal to minus 12. It's not possible to have a negative length. So x must be 4. Thus, the distance from A to D is 4 centimetres. So part 3 wants us to calculate the distance from D to E. So from D to E. So I've labelled that as y. And I've filled in now that AD is 4 centimetres. We got AD to be equal to 4 centimetres from part 2. So by theorem 13, taking the sides opposite angles 2 and 1. So this is angle 1, and the side opposite is 8. And this is angle 1, and the side opposite is now 4 centimetres, because we found x to be 4. And this is angle 2, and the side opposite that is 10. And this is angle 2, and the side opposite that is y, which is what we're trying to find, the distance from D to E. So again, we set up our fractions. So we're going to have y over 10, because they're corresponding sides. So y over 10 equals 4 over 8. So equals 4 over 8. So again, I'm taking the smaller triangle's side lengths to be the numerators and the larger triangle's side lengths to be the denominators, but you could have turned them upside down. It doesn't matter which way you do it. So now we just have to solve for y. So we have y over 10 equals 4 over 8, so multiplying both sides by 10 we'll get the y on its own. So we get 4 multiplied by 10, which is 40 over 8. 40 divided by 8 is 5. So y is equal to 5, therefore DE is equal to 5. So the distance from D to E is 5 centimetres. Theorems 11, 12 and 13 form the basis of the formal proof of Pythagoras' theorem, one of the foundations of geometry.